Welcome to the atmosphere. We're going to start at the bottom and work our way up. And at the bottom of our atmosphere is the layer called the troposphere. This is the layer that's closest to Earth. It is the densest layer. What happens here is that the temperature begins to decrease as you go up in this layer. And if you've ever been camping in the mountains or hiking up a mountain, then you know what that feels like, that it usually tends to be colder, especially at night. This is where all of our weather occurs. So when you look up and you see clouds raining, they are just in that bottom layer of our atmosphere. After we go through the troposphere, we come to the next layer called the stratosphere. Here the air is very thin. There's not much moisture here. In this layer we have the ozone layer. The ozone layer is really important to us because that's what absorbs the harmful rays of the sun. In this layer, the temperature actually increases. So where before we said in the troposphere it gets colder as you go up, well now it does the opposite. When you get into the stratosphere, the temperature increases. It's getting hotter. Now, not much happens in this layer. You might have a few airplanes that fly at the very bottom of the stratosphere, but you don't really go above much higher than the stratosphere. After the stratosphere is the mesosphere. Meso means middle, so that's an easy way to remember where this layer is. It's in the middle of our 5 layers. The mesosphere is known for its extremely cold temperatures. As you go up in this layer, the temperature drops off dramatically, and because of that, it's able to burn up meteors that come our way. Now, usually when you think of the word burned up, you think of something being really hot. But really what's happening in this case is it's almost freezing them or shattering them, and they break apart. We have meteors come to our planet almost daily, but thanks to the mesosphere, it breaks apart and destroys most of them. Usually you see this in the sky as what most people call shooting stars. So really, they're not shooting stars at all. It's meteors that are being broken apart in our atmosphere. There's really no such thing as a shooting star. After the mesosphere comes the thermosphere. This is the thickest part of our atmosphere, and it also has the most extreme temperatures. Here, the temperatures rise dramatically, unreasonably hot. But because it's so far up, there's very low density. There's not a whole lot of air molecules here. Also in this layer, we have another layer called the ionosphere. The ionosphere is a layer of charged particles, and we'll talk more about this in class, but it allows radio waves to travel farther distances. The last layer is the exosphere. This layer has practically no air molecules, and it really just sort of fades into space. And this is why some places or scientists don't recognize this as a separate layer. You might see in some worksheets we do or videos we watch that people say the thermosphere is the top layer, because really the exosphere is just kind of fades or blends into space. There's not much happening here. On the next slide, you're going to watch a short video that recaps the layers of the atmosphere, and they don't mention the exosphere. But just know that it is sort of the boundary as leaving our atmosphere and entering into space.
Atmosphere.
Atmosphere. What is it? Is it A, the realm of nightmares found in Greek mythology? B, a species of 3-headed atomic monsters? Or C, a sphere of gas enveloping the Earth?
The atmosphere is a spherical envelope of gas that surrounds the Earth. It's sort of like a shield because it protects us Earthlings from the sun's harmful rays. At the same time, it allows enough solar energy to come through to warm our planet.
Not to mention, the atmosphere is the air we breathe. It provides us Earthlings with the oxygen we need to live.
So let's get a load of it. Like, what's it made of and what does it look like?
The atmosphere is made of gas. 21% of this gas is oxygen. Can you guess what the other 78% of it is?
The majority of the atmosphere is made of nitrogen.
Because it's made of gas, the atmosphere is sort of invisible. Even so, it has a detectable structure.
The atmosphere is organized into several layers. From bottom to top, these layers are the troposphere, stratosphere, mesosphere, and thermosphere.
Let's pretend it's Halloween. Forget the suburbs. You're going trick-or-treating in each layer of the atmosphere. But if you're invited inside for a cup of hot cider, you have to be careful. Some atmospheric layers are inhospitable to humans.
Layers of the atmosphere.
Let's start with the layer closest to Earth, the troposphere. This is the layer we humans live in. It's where you find clouds and weather and pollution and humidity. The troposphere is the densest layer of the atmosphere. It contains most of the atmosphere's mass.
Above the troposphere, we have the stratosphere. Want to know something cool about the stratosphere? It contains the ozone layer.
Ozone is just a molecule made of 3 oxygen atoms. Ozone is really good at absorbing harmful ultraviolet radiation from the sun. So the ozone layer is super important to us humans and our ability to survive on Earth.
Moving on up, we arrive at the mesosphere. The mesosphere is the coldest layer of the atmosphere with temperatures as low as negative 93 degrees Celsius. That's cold beyond your coldest dreams.
And finally, we have the topmost layer of the atmosphere, the thermosphere. The thermosphere absorbs wicked amounts of solar radiation, causing it to have temperatures as high as 1,000 degrees Celsius. Yikes, that's hot!
Well, not exactly. You see, even though the thermosphere has very high temperatures, it's not hot. Can you guess why?
It's because temperature is not exactly the same as heat. Temperature just means the particles of gas are moving quickly. Heat, on the other hand, is a transfer of energy that occurs when one particle comes into contact with another. But the gas particles in the thermosphere are spread so far apart that they rarely touch each other. So, even though the thermosphere has a lot of energy, you wouldn't experience it as being hot.
So we've got troposphere, stratosphere, mesosphere, and thermosphere. Who's got a good way to remember that?
Trolls stupidly mash thermometers. Troposphere, stratosphere, mesosphere, thermosphere. Trolls stupidly mash thermometers.
You may be wondering, how did we end up with these different layers of atmosphere? How did they get organized like that?
Well, for one thing, you may have noticed that layers of the atmosphere are partially organized by temperature. The temperature of a layer depends on how much solar energy it absorbs, and this depends on the types and amount of gases in that layer.
Another defining feature of atmospheric layers is air pressure.
Check it out. The layers of the atmosphere are held in place around the Earth by gravity, right? That's why the layer closest to the planet has the highest concentration of gas molecules, because gravity's pull is strongest there.
The effect of all these gas molecules being pulled towards the Earth causes the molecules to push down on the planet. This pushing down is called air pressure.
The higher you go in Earth's atmosphere, the lower the air pressure. The lower the air pressure means fewer molecules to breathe. That's why mountaineers who climb to the top of Mount Everest usually need to bring cans of oxygen with them. In fact, for some mountaineers, the greater feat is not just to summit Everest, but to do it without oxygen.
I recall the time I climbed to the top of the university library without the aid of an oxygen tank. I thought I would be assisted by my animal spirit guide, the flying squirrel. But I was a fool. Turns out flying squirrels are all smokers. They have almost no lung capacity.